So Peter, thanks for being with us here today. I was wondering if you can describe quantum mechanics to us in simple terms.
In simple terms, probably very difficult because it's the way that we look at the world at the microscopic level. And a lot of our intuition about how we think of the world in terms of classical terms does not apply. And so it's really counterintuitive. In the quantum world, energy comes in discrete packages. Those discrete packages allow a quantum system to jump from one level to another. That gives you lasers, it gives you semiconductors, it gives you superconductors. The jump word is important because it's probabilistic. Intrinsically, the quantum world is intrinsically random. Classical world is deterministic. So many things that we perceive in the classical world do not apply when you start to look at the microscopic level. What we're trying to do with the new sort of quantum mechanics that we're exploiting now is to use the fact that you can do something completely counterintuitive. You can put quantum systems in more than one state at once. You can put it here and here at the same time. Now that's counterintuitive. So the way you perceive the world is going to change dramatically when you get to these sort of scales. And of course, the trick of what we're trying to do now is to extend this quantum mechanical weirdness into bigger and bigger systems that have a utility, but also tell you a lot more about the external world.
What is quantum technology and how does it use some of those weird rules in quantum mechanics?
Quantum technology is the exploitation of this for some sort of engineering product that has value that you're going to use. So what we're looking at is ways in which we use this in novel sorts of sensing, in timing, in the ability to communicate in a different way, and also, finally, to actually compute things in a different way with quantum computing.
So moving on then, what can quantum technology actually do for us on a societal scale, and why do we need it at this time?
You got here today using quantum technology. You would use sat-nav. And sat-nav works because what you're doing is communicating with a constellation of satellites with atomic clocks. And in those atomic clocks are atomic systems that are processing around coherently between this state and that state simultaneously. So just to get here today, you use quantum technology.
What are some of the most exciting advancements in quantum technology that have happened recently, and how are they going to affect our lives in the next 5 to 10 years?
Right, in the next 5 to 10 years is a key question. Quantum computing is difficult, and it may take a decade to produce a machine of scale. Mainly because these quantum bits that we're exploiting are fragile. They're fragile because they talk to the external world, but that's what you need in a sensor. So sensors are immediate, we can do something about it now. So for example, I can put a lot of these little quantum sensors, and I think it looks like a cycle helmet, and I can monitor brain activity. That's already being used to treat juvenile epilepsy in hospitals around the world. That journey from discovering the fragility of quantum bits to exploiting them in brain imaging has taken just a few years.
What role does creativity play in scientific research?
If you think about a transformational change in the way that you understand the world, you undermine all of the things that were your preconception of the way the world works. The business of art is to actually understand how you perceive the world and how you then display it in a way that challenges your perceptions. And of course, transformational change between one school of thinking and another, it's not just artists that have done that between the classical world, Impressionism, post-Impressionism, abstract art. It's how physics has changed as well. And it's always done by that next generation. So old geezers with grey beards might actually stick to the way that we always think about things. New people say, well, why do you do that? Why can't we do something a little different? And what you'll see in the quantum world is the next generation transforming the way that we understand the world, just as artists do.